If you've been following my channel, you know that I have a kiln. And it was simple. It was just a cardboard box with a fan from a computer, and I later added some temperature controls, which I'll talk a little bit about in this video. But it was time to upgrade that kiln to something a little bit larger and a little more efficient. So I've got a mini fridge, and it's time to upgrade my existing kiln. So before I do that, I want to remove a few things just to get rid of them. I have a compressor here. Now this is a newer mini fridge, so it does not contain Freon, so I'm not concerned about that. But it does contain coolant. So I'm just going to pinch the lines off here and here. And then once I pinch them, I'll cut them. And then I'll remove that and take it to a recycling center. I'll also just cut out all the electrical wires. It's unplugged, so it's totally safe. That way I don't have to worry about it in the future. All I'm interested in this as a fridge, from a kiln point of view, is an insulated box. So here's my fridge, which is going to be my kiln. First thing is I have a heat source. That's a light bulb. Yes, a 100-watt light bulb will generate a lot of heat. So the first thing I need to do is run this extension cord. I'll wire it up to this bulb, run it out along the bottom here and out the side, and all my plugs, controls are going to be on this side of the fridge over here. My controller and my electrical plug. So let's get started with that. Drill a hole in the side here and run our cord through. I'm actually on the other side of the fridge, just drilling through. You can see the drill poke through there, and that's where I'm going to run my cord. One thing I do have to be careful of is I am drilling a hole through metal on the outside, so I want to make sure that that doesn't fray. So I'm going to fill that hole after I run the cord through. I'm going to fill that hole with hot melt glue, which will just provide a grommet to just prevent any chafing on the sides. So my light is wired up. The wire sits on the bottom of this. This should be mounted on a box. I'm just going to make a spacer for that to sit up on so that the cord, it's not sitting on the cord. And then I'll just hot melt the cord into this bottom track and out the side so that it won't move around. So now I've just glued my controller on here to the side. I just used CA glue. This is the controller, this is the plug. That controls the light bulb. So the light bulb will plug into there. The heat source will come off and on. We'll talk about the controller in a bit. The fan is going to be mounted on the top, and it's going to be constant power. So we'll work on that next. I had mentioned I need a spacer. I just cut this out on my laser engraver as well. CA glued it into place, and then CA glued the light on top of that spacer. Now I'm drilling the holes in the side of the mini fridge. I'm going to have one on each side, and this is to allow airflow intake into the kiln. I'm also cutting a starter hole at the top for my fan, and then I use my jigsaw to square it up. The outlet to the fan was square. Once that's been cut, again I just use CA glue to glue this into place. CA glue worked quite well. It's quick and it gives a nice tight bond. Once these are in place, I'll go back later with some silicone, as I'm doing here, just to silicone around the edge. Give you a little bit of an idea, the fan is not quiet, it's fairly noisy. I cut out a circle on my laser engraver. You don't need a laser engraver. You're a woodworker, you can cut it any way you want. And I put a bolt through it, and this is my adjustment for air intake. And you can see the light bulb just went out. So I do have a controller. The way this works is you set a set point. Right now it's at 70. The actual temperature inside the kiln is 70.1, so therefore it killed the power to the switch that's supplying the light bulb. So the way I've set my kiln up is that it runs the fan continuously. Fan is here, runs that continuously, and runs the light bulb as a heat source as required. So the temperature will drop down here, and when it does, then the light bulb will come back on. You can see it starting to drop already. So once that drops down, then the light bulb will come back on. I'm going to go ahead and set it up to 75, which is where I'd want to run it most of the time, and we'll see how it is at maintaining that temperature. So my set point is now at 70. The light bulb is back on. I've restricted the air on this side. I have another one on the opposite side, and it's open a crack. There's still lots of air coming out the top. There are leaks. It's going to pull a vacuum. That fan is strong enough that if it doesn't get enough air supply, it will pull a vacuum. You can see there's the seal here around the door is not 100%. So it's going to get air regardless of where my dampers are. And again, you can see here in a short period of time, the temperature's coming up fairly quickly. The power just was shut off and the light bulb has gone out. It came up to temperature from 70 to 75 in a matter of about 5 minutes. Just an update, after this test, I took it up to 80 degrees Fahrenheit, and it worked quite well. It was able to maintain that temperature. If I need to go higher, which I don't know that I will, I can always go with a larger bulb. Right now it's a 100-watt bulb.